Welcome to section 3.3, solving multiplication equations. Yesterday we did solving addition and subtraction equations, and we used the inverse operations of addition and subtraction. So if you remember, the inverse of addition was subtraction, and the inverse of subtraction was addition. Well, when I solve an equation with multiplication in the problem, the inverse of multiplication is division. And in order to solve that, we use the division property of equality, which is what we're going to be talking about today. Okay, so the division property of equality says if you divide each side of an equation by the same non-zero, it has to be non-zero because if you can't divide a number by zero, it doesn't work. Same non-zero number, the two sides remain equal. And once again, to demonstrate this, we know that 8 equals 8. So if I divide 8 by 2, I will get 4. So whatever I do to the one side, I must do to the other to keep it equal. Okay, and equal doesn't mean I keep it the same number. It means I keep both sides representing the same value. So I have the equation 2x equals negative 6. So whatever 2x is equal to the negative 6. Okay, 2x means 2 times x. So I can take 2 times x and divide by 2. Now, 2 divided by 2, guys, any number divided by itself equals 1. Okay, so 2 divided by 2 is 1, which would actually leave me with 1x. Negative 6 divided by 2 is negative 3. What's 1 times any number? Well, 1 times any number is that number, so I'm left with x equals negative 3. So that's why when I divide, it doesn't equal 0. 2 divided by 2 does not equal 0. Okay, it equals 1. And 1 times x would just be x. Okay? So when I solve this problem, 20 equals 4x. I want to get x by itself because that's what I want to know, what number that represents. So using the division property of equality, I'm going to divide both sides. And I'm dividing it by the number that's on the same side as the x. Okay, because I want x by itself. That's the whole point. So 4 divided by 4 and 20 divided by 4. Well, 20 divided by 4 is 5. 4 divided by 4, because we said before, is 1, and I'm left with x. 1 times x is x, so x equals 5. And then we can check it. So for our check, we want to know if 20 equals 4 times 5. Well, because we all know our times tables, 4 times 5 is 20, so it checks out. That means I found the right solution for x. Remember, this is your answer. This is just your check. Okay? For the next one, I have negative 8 times y equals 24. So when I divide, I don't divide 8, I have to divide a negative 8. A negative divided by a negative is a positive. And negative 8 divided by negative 8 is 1. So I'm left with 1y equals 24 divided by negative 8. A positive divided by negative is a negative. 24 divided by 8 is 3. Okay, 1 times y is y. So y equals negative 3, and that is my solution. So once again, we're going to check. I want to know if negative 8 times negative 3, which is my y, would equal positive negative 24. Well, we know a negative times a negative is positive, so we're good there. And 8 times 3 is 24. So that checks out as well. Okay? And our last one. Once again, I'm solving for d. All right? So if I'm solving for d, I need to get rid of the negative 9. It's negative 9 times d, not minus 9. Okay, so I'm getting rid of the times. Opposite of times is division. That's negative 9. So I divide both sides by negative 9. Negative 72 divided by negative 9 is a positive 8. Negative 9 divided by negative 9 is 1. And I'm left with a d as well, 1d. Well, I know 1 times d is d. So my solution for d is 8. Okay, and we're going to check that out again. I want to know if negative 72 does it equal negative 9 times 8. Well, we know a negative times a positive is a negative, and 9 times 8 is 72. So this one checks out as well. Okay? Checking your answers is the easiest way to make sure that you're doing every single problem correctly. All right? Now tomorrow in class we're going to review addition, subtraction, and multiplication problems to make sure that you understand how they all correlate together, and so you can easily see when you're supposed to use which operation when. Okay? So make sure you're now good with using division property of equality, addition property of equality, and subtraction property of equality. Okay? And as always, we're showing the same thing is done to both sides. That is very important that you make sure you show the same thing is done to both sides, because that is showing that you know how to use the property of equalities. Okay? Thanks for watching again, and you'll hear me later.